Hello, this is Mr. Ensler. Today I'm going to be going over the Chapter 7 quiz. It's basically like a practice test. So in numbers 1 and 2 we are solving the system of equations by graphing. Basically we just graph both lines. So in number 1, that's already in slope-intercept form. I'm going to start at 3 on the y-axis. And then my slope is 2, as in 2 over 1. So I'm going to go up 2 over 1. It's positive. So that means you start by going up. But if I want to make more dots, I can also go down 2 and to the left 1. Just continue that pattern on. Alright, so then you get out your straight edge and you connect those dots into a line. And then we have our other equation right here. That equation has a y-intercept of -1. So we'll start down here at -1. Its slope is also positive 4. So 4 over 1. So we're going to go up 1, 2, 3, 4 over 1. Up 1, 2, 3, 4 over 1. You can see where they cross. Up 1, 2, 3, 4, and we're off the graph. Then I can go back down 1, 2, 3, 4, left 1. And so I'll connect the dots and make that into a line. Okay, so you can see the spot where they cross is right here on this point, and so that point, if you name it, you have to go from the origin, you have to go over 2 and up 7. So our answer is 2, 7. Okay, in number 2 we're going to graph both of these equations also, but the equations are not ready to be graphed yet. We like to graph equations in y equals mx plus b form. Basically, we like to get the y by itself. So in the first equation, what we need to do is subtract x from each side. That way it will go away from the left side and y will be by itself. Now we have y equals -x, and then we still have that 0 there if you wanted to show that. And so to graph that, you're actually going to start at 0. This starts at the origin. And the slope of negative, that's really like -1 over 1. So you're going to be going down 1 over 1, down 1 over 1. And you can even go the other way, up 1, left 1, up 1, left 1, up 1, left 1. Then you're going to connect that with a straight line. Okay, now for the other equation. The other equation, we got to get y by itself also. So we're going to subtract the 3x. When I rewrite that, it says y equals -3x minus 8. So with that one, I will start down at -8. And this has a slope of -3, as in -3 over 1. So I go down 3 over 1. I would end up somewhere around there. For this one, I definitely am going to want to do the opposite of going up 3 and to the left 1. And then I'll do it again. Do it again, and we're getting close to them crossing. 1, 2, 3, and over 1. There's the point of intersection. I'll do a couple more. So then I'll draw a line and connect those. Alright, and we can see that these cross at a single point also, right there. And so you'd have to count where that is from the origin. And so from the origin, we go 1, 2, 3, 4 to the left, and up 1, 2, 3, 4. So that is point -4, 4. In numbers 3 and 4, it says solve using substitution, and I left a hint there for you. Start by getting one of the variables by itself. So of these 4 variables, we have an x, a y, and then another x and another y. We have 4 choices. You want to get one of those by itself. Now, any of those would really work, but there's often one that's a little easier. In this case, that's the bottom y, this one right here, because it's already a little bit by itself. But to get it totally by itself, we need to get rid of this -3x. So we will add 3x to both sides of that equation. So now I'll have y equals, and if you want to just leave it in that order, you can, 11 plus 3x. And now the main part of substitution is where you're going to take what y equals, 11 plus 3x, and you're going to plug it into the other equation for y. So we'll write out that other equation, 2x plus 3 but instead of writing y, we're going to put in what y equals, 11 plus 3x. And then that still equals 1. So I've written out this top equation, but I put in 11 plus 3x for y. Now we need to go down here and actually multiply, distribute this out, add like terms, and solve it. So the 2x just stays there. When I distribute, the 3 times 11 is 33. The 3 times 3x is 9x, and that equals 1. I can combine these two like terms. 2x and 9x are the same, so 2x and 9x, you add those together, you get 11x. Now I just need to get the x by itself, so I'll subtract 33 from each side. 11x equals 1 minus 33 is negative 32. And then I just need to divide both sides by 11. And when you divide both sides by 11, you get x equals, you'll probably want to type that in your calculator, negative 32 divided by 11. And it doesn't come out evenly. So you can round to negative 2.9. That would be just fine. And so that's one of our answers. Now what we have to do is take that one answer that we know and plug it back into one of these equations up near the top. One of these full equations that has both an x and a y in it. You can choose any of these three. I usually like to choose this one that I made that starts with y equals. So I'll substitute that in. Y equals 11 plus 3, but instead of writing x, I'm going to put what x equals, negative 2.9. And now I just need to figure out what that equals. So 3 times negative 2.9, I'll just enter that into my calculator, and you get negative 8.7. And then I have to add negative 8.7 and 11, so I'll just press plus 11. And so y equals positive 2.3. And so that's my answer. I'll write it out as an ordered pair. Negative 2.9, positive 2.3. What that means is if you would have graphed these two original equations, this is where they would have crossed. It would have been really hard to see that that's exactly where they crossed by graphing. That's one of the reasons why we use substitution, or our other method, elimination, is because you can't always figure out the answer from a graph. Alright, number 4, same type of thing. We have to get one of the variables by itself. I would suggest that this top x would be the easiest to get by itself since it doesn't have a number by it. So I would want to subtract 3y from both sides of that. And so I have x equals, you can put this in whatever order you want, 6 minus 3y, or you could have put negative 3y plus 6. Now what we'll do is we're going to substitute what x equals into the other equation for x. So now I'll write out that other equation. 6y plus 2, but instead of writing x, I'm going to write what x equals, 6 minus 3y. And then I got to finish that equation, equals 12. Not sure why I have that plus 12 there. You can just cross that out if you want. Alright, now I have to distribute this 2, so 2 times 6 is 12. 2 times negative 3 is negative 6y equals 12. Usually, then I can combine some like terms, so I have this 6y and this negative 6y. And actually, 6y and negative 6y, they just cancel each other out. So I have 12 equals 12. Uh-oh. This is one of those weird situations where the variable drops out completely. I don't have any x, I don't have any y in this equation. And so that means it's one of those special types where there's either no solution or infinitely many solution. If these two numbers don't equal each other, if you have a false statement, that would be no solution. But in this case, these two numbers make a true statement. 12 really does equal 12. And so my answer here is infinitely many solutions. What it means, if I graphed this, is that these are actually the same exact line. I know they don't look like it up here at the top, but if you put them both in y equals form, they would actually be the exact same line. Alright, the next Couple problems say solve using elimination. This is where we line up the variables and then we add or subtract. Sometimes we have to multiply first. So we want to line them up. So notice how these m's are right on top of each other. That's good. But look at the next set. I have negative 13 and positive 2n. Those aren't lined up. Those aren't like terms. And same thing on the end here. Negative 2n and 7. Those are not lined up. So I have to change one of the equations to make it so that they're lined up. I kind of like the way this second equation is. I have variable equals number. Maybe I'll make the first equation look like that. So the first thing I'm going to do is add 13 to move that 13 over to this side. So now that says 3m equals 2n plus 13. But they're not the same yet. This equation that I like says m and 2n. So I need this to be m and then an n over there. So to get it to look like that, I'll subtract this 2n from both sides. So I'll put it over here now. Now it says 3m minus 2n equals 13. And so now I have my equations there lined up, and I need to add or subtract to get rid of one of the variables. Now if I added the m's, I would have 4m. If I subtracted, I would have negative 2m, so neither one of those is going to do me much good. The n's, if I added them, they would actually go away, which is what I want. The whole reason why this is called elimination is to get rid of those variables. So I'm going to draw a line underneath. I'm going to put a plus sign here to show that it goes for all of it. So 1m plus 3m is 4m. 2n minus 2n, 2n and plus negative 2n, that goes away. And so there's nothing there. 7 plus 13 is 20. Alright, now I have a small little equation here. I'm going to divide both sides by 4. So m equals 5. That's one of my answers. Now, just like using substitution, what we're going to do is we're going to take that m equals 5, and we're going to put it back into one of our equations for m in order to get n. So I'm going to take this equation right here, this m plus 2n equals 7, and I'm going to reuse it down here, but instead of writing m, I'm going to put in 5, since that's what m equals. So it'll look like this. 5 plus 2n, that's supposed to say 2n, equals 7. And now I just solve that little equation. I'll subtract 5. 2n equals 2. So what number times 2 equals 2? That would be 1. So there are my two answers. Alright, with number 6, you can see that all of the terms are actually lined up. We have x's, y's, equals, numbers. Everything's lined up, so we don't have to change that. But it won't work in this case just to add or subtract. If I added the x's, I'd have 5x. If I added the y's, I'd have 3y. Nothing would go away. Nothing would be eliminated, which is what I want. If I subtracted them, 2 minus 3 is negative 1. That wouldn't go away. For the y's, negative 1 minus 4 is negative 5. That wouldn't go away. So sometimes what you have to do is multiply one or both of the equations. So there are many different ways how to do this. You either have to get rid of the x's or the y's. And what you want to do is make the number in front, the coefficient, you want to make those numbers the same. So I could either try to make 2 and 3 the same, or I could make this 1y, negative 1y, and the 4y the same. And I'm going to choose the y's, and you'll see how this goes. What I'm going to do is I'm going to multiply this top equation by 4. And that's how I show it. You put an arrow and you put a number over it, and that tells what you're multiplying everything by. So I'm going to multiply all of these numbers by 4. And so what I'll have is 8x minus 4y equals 24. And so now I'm going to take these two equations and I'm going to add them. Because what will happen is when I add them, the y's will go away. I'll also get 11x, and then negative 2 plus 24 is 22. So I come up with this rather simple equation, and I think 11 times what number equals 22? X would have to be 2. And so now I take this 2 and I plug it into one of the original equations. choose either one. I'll just choose this first one here. So I'll have 2x, but now I know x is 2, minus y equals 6. So that's 4 minus y equals 6. I'll subtract 4 from each side. I'll get negative y equals 2. So this is saying the opposite of y is 2. You could divide by negative 1. And so y equals negative 2. So I have most of my answers. I'll write it out as an ordered pair. 2, negative 2. And that's my answer. Alright, let's flip. And so now I am on the back. And I have another elimination problem. So they're all lined up. That's good. But none of the numbers for the variables are exactly the same. So we need to make that happen. How about this time I'll get rid of the x's. Now you got to think, I need to multiply the 4 and the 3 by numbers that will make the 4 and the 3 the same. And so you want to think, alright, how could I make them the same? You don't have to write this out, what I'm going to do here, but what you can do is you can say, okay, if I have 4, if I multiply that by numbers, what could 4 become? So if I multiplied it by 1, it'd just stay the same, 4. If I multiplied it by 2, it's 8. If I multiplied 4 by 3, I'd get 12, and so on. And so 16, 20, 24, and so on. And what about if I did the same thing with 3 for the 3x? Well, there I'd have 3, 6, 9, 12, 15, and so on. And so what you see is that I can make both the 4 and the 3 into 12. So I'll take the first equation. If I want to make that 4x into 12, I'm going to multiply it by 3. That way I'll have 12x, but then I still have to multiply the rest by 3. Even though I am not getting rid of that, I still have to multiply it by 3. So I have minus 21y equals 30. Alright, so what do I have to multiply the second equation to make that x into 12x? 4. 4 times 3 equals 12x. And actually, I'm going to multiply it by negative 4, because then it will become negative 12x. And what I'm going to be doing is adding these. So when I add them, those will go away. And it's just easier to add. So I also need to multiply negative 4 times 2y and negative 4 times negative 7. So I'll complete that here. Negative 4 times 2y is negative 8y. Negative 4 times negative 7 is positive 28. So I need to add those. When I add the y's, I get negative 29y. Add 30 and 28 and you get 58. Okay, so then let's figure out y's. Let's divide by negative 29. And that does actually come out evenly. Y equals negative 2. Alright, so just like in all the others, once you know what one of them equals, plug it back into one of the originals and see what the other one equals. So I'll just go ahead and plug this into the first one. So I'll have 4x minus 7, but instead of writing y, I'm going to write negative 2, and that equals 10. And now I just need to solve this. Alright, I have negative 7 times negative 2. Negative 7 times negative 2 is positive 14. And then I'll subtract 14 from both sides. That it will equal negative 4. Divide by 4. And I have x equals negative 1. So now I know both my x and my y. I can write it as an ordered pair. Negative 1, negative 2.